Hey guys, how's it going? This is FixerMed. Welcome back to my ECG Skills Builder Workshop, where I'll be covering all the fundamental knowledge and skills you'll need to read and interpret an ECG graph in a quick and effective manner. This will be part 4 of my multi-part video series of doing so. So without further ado, let's go ahead and get started on today's content. So I'd like to open up today's video by talking about how the ECG graph is represented on graph paper. When you're looking at the horizontal axis, a small block typically is a representation of 0.04 seconds, while a large block is typically a representation of 0.2 seconds. While on the vertical axis, the unit of measurement that is utilized there is the millivolts, so that represents the electrical voltage. And a small block there refers to a measurement of 0.1 millivolts, while a large block represents a measurement of 0.5 millivolts. So small block, large block. Large block is typically made out of 25 small blocks. So 25 small blocks make up one large block. One small block is one small block. Pretty easy. And yeah, that's all I have for ECG graph representation on the graph paper. Moving on, let's go ahead and talk about the waveforms you'll be seeing on these ECG graphs. So ECG waveforms are made up of P waves, the QRS complex, and T waves. Some of the segments and intervals you'll see here also include the PR interval, the ST interval, and the QT interval. The U wave makes an occasional appearance depending on various differential diagnoses. The J point marks the end of the QRS complex and the beginning of the ST segment. A nice visual representation of an ECG waveform can be seen on the picture to the right. Let's go ahead and break these components down one by one for a higher level of understanding from a basic sciences standpoint. So for waveforms, the P wave represents atrial depolarization, indicating the initiation of the cardiac cycle. The QRS complex represents ventricular depolarization followed by ventricular contraction. The T wave represents ventricular repolarization, preparing the heart for the next cycle. Moving on to segments and intervals, the PR interval indicates the time from atrial depolarization to ventricular depolarization, reflecting atrioventricular conduction time. The ST interval represents the period between ventricular depolarization and repolarization, crucial for assessing myocardial ischemia or injury. The QT interval represents the total time for ventricular depolarization and repolarization, indicating ventricular refractoriness. Other ECG elements, as we mentioned earlier, the U wave occasionally appears after the T wave, but it's thought to represent the repolarization of the bundle of His Purkinje system or late repolarization of the ventricles. The J point marks the end of the QRS complex and the beginning of the ST segment, significant for detecting myocardial ischemia or injury. We'll be looking more into the U waves and J points in future interpretation videos. So, moving on, let's go ahead and see if you guys retained any of the information from this video with some quick recall questions. What does the horizontal axis represent in an ECG graph, and what units are used to measure it? All right, I think I gave you guys enough time here. If you need more time, please feel free to pause the video. Otherwise, moving on to see what the correct answer is. The horizontal axis of an ECG graph represents time duration, with small blocks typically equal to 0.04 seconds and larger blocks which represent 0.2 seconds. This axis allows for the visualization of the temporal sequence of cardiac electrical events, aiding in the diagnosis of cardiac rhythm abnormalities and conduction disturbances. Therefore, the correct answer is B, time duration in seconds. Let's go ahead and see why the other answer choices are incorrect. Heart rate in beats per minute. Heart rate is derived from the ECG by measuring the intervals between successive R waves, which is a function of time represented on the horizontal axis rather than being directly plotted on it. Electrical voltage in millivolts. Electrical voltage is represented on the vertical axis of the ECG graph. The horizontal axis specifically denotes time duration. Frequency in hertz. Frequency may be indirectly related to heart rate, but it is not a direct measure plotted on the time axis of an ECG graph. Cardiac output in liters per minute. Cardiac output is a physiological parameter related to the heart's pumping function but is not directly represented on the horizontal axis of an ECG graph. Moving on, let's go ahead and take a look at another problem. Which ECG waveform or element represents the period between ventricular depolarization and repolarization crucial for assessing myocardial ischemia or injury? Alright, I think I gave you guys enough time there. If you need more time, please feel free to pause the video. Otherwise, moving on now. The ST interval represents the period between ventricular depolarization and repolarization. It is crucial for assessing myocardial ischemia or injury, as deviations from the baseline ST segment can indicate abnormalities such as myocardial infarction. Monitoring changes in the ST segment over time can provide valuable clinical information regarding cardiac health and potential ischemic events. Therefore, the correct answer is D, ST interval. Let's go ahead and take a look at why the other answer choices are incorrect. P wave. The P wave represents atrial depolarization, indicating the initiation of the cardiac cycle. It is not directly related to the period between ventricular depolarization and repolarization. QRS complex. The QRS complex represents ventricular depolarization followed by ventricular contraction. It does not specifically represent the period between ventricular depolarization and repolarization. T wave. The T wave represents ventricular repolarization preparing the heart for the next cycle. It is not directly related to the period between ventricular depolarization and repolarization. QT interval. The QT interval reflects the total time for ventricular depolarization and repolarization, indicating ventricular refractoriness. While it includes the period between ventricular depolarization and repolarization, it is not specifically focused on assessing myocardial ischemia or injury. Let's go ahead and take a look at another question now. Which ECG waveform or element represents the time from atrial depolarization to ventricular depolarization, reflecting atrioventricular conduction time? Alright, I think I gave you guys enough time there. If you need more time, please feel free to pause the video as always. Moving on now. The PR interval indicates the time from atrial depolarization to ventricular depolarization, reflecting atrioventricular conduction time. It encompasses the duration from the onset of the P wave to the beginning of the QRS complex. Monitoring changes in the PR interval can help diagnose conduction abnormalities such as atrioventricular block. Therefore, the correct answer here is C, PR interval. Let's go ahead and take a look at why the other answer choices are incorrect. P wave. As always, the P wave represents atrial depolarization, as we discussed earlier, indicating the initiation of the cardiac cycle. While it is related to the atrial electrical activity, it does not specifically measure the conduction time from atrial to ventricular depolarization. QRS complex. The QRS complex represents ventricular depolarization followed by ventricular contraction. It is not directly related to the time from atrial to ventricular depolarization. ST interval. The ST interval represents the period between ventricular depolarization and repolarization, crucial for assessing myocardial ischemia or injury. It is not specifically focused on reflecting atrioventricular conduction time. U wave. The U wave occasionally appears after the D wave and is thought to represent repolarization of the His-Purkinje system or late repolarization of the ventricles. It is not directly related to atrioventricular conduction time. That will do it all for the video today, guys. As we move along, we're going to get closer and closer to interpreting ECG graphs, so bear with me. If you understand all these basics right now, getting to the graphs at a later time will be a much better experience, and it will be a piece of cake compared to going into looking at them blind without understanding the basic science principles behind them. So I thank you guys for your attention throughout this whole video. If you have any questions, comments, or concerns, please feel free to leave them in the comment section below. If you like this type of video, please be sure to leave a like and subscribe for more content like this. Otherwise, that's all I have for today. This is FixerMed signing off. Be sure to have a great day, everyone, and good luck studying.